Hello everyone. Today we are going to discuss about molecular nanoelectronics and nanobioelectronics. It's a very interesting topic as it is merging both molecules and technology together and creating a vast subject. As we all know, picture is worth a thousand words, which is a quote by a famous man. So diving into the topic, first we are going to have a brief about nanobioelectronics. It's basically bridging a gap between biology and technology and getting both subjects into one field and making advanced electrical components. So first we are going to have an introduction about nanobioelectronics, then key concepts and principles about it, then applications of nanobioelectronics, which are very useful and interesting, then recent advancements in the field. Then finally, we are going to see about future prospects and challenges which we are going to face while developing them. So, coming to the definition of nanobioelectronics is nothing but, as we already discussed, combining nanotechnology, biology, and electrical components to create very advanced devices and systems. Its significance is basically very high as it has very innovative approaches to the problems which we are going to face in the future. Uh, the revolutionary fields now currently are many, but one of them is nano materials. And particularly nanobioelectronics is very revolutionary because it's can change the whole perspective of humankind, visualizing the biological systems. So, further going into the topic, the key concepts which it contains is, as we all know, nanoscale materials, due to their size, exhibit different unique properties, which is very helpful for us. The second key concept is bio-nano interface. Bio-nano interface is nothing but just an interface between the biological systems and electronic systems, by which we can develop many inheritance and other biological developments inside the body to avoid many diseases, transmitted diseases, etc. Uh, and we also can observe the biological systems very keenly. Then next comes electronic sensing. Use of electronic devices to detect and measure biological signals with high sensitivity and specificity. As nanoparticles are very minute, they can enter the biological body very easily and observe the inner part of anything very aptly and analyze it properly. It can give a basic idea about what a patient or any biological thing is suffering with or going on. It's going to be very interesting. So, coming to its applications, first is, as we already discussed, medical diagnostics. We can monitor the health conditions of a patient. We can the uh, personalize the medication of the patient so that he might improve from his condition. Then comes environmental monitoring. We can also check the pollutants in the air, water, and soil. So we can easily detect the unwanted chemical compounds and completely eradicate them so that there may be not any further complications. Then comes advanced computing. As we all know, bio interfaces nowadays are very developing. The technology nowadays is very fastly trying to improve, and the nano electronics is one of them. So, in a very minute space, we can have data storage, computer efficiency, and processing capabilities, so that the we can perform many tasks as fast as we can. Then comes, as you can see, how we can analyze the things which are inside a computer and develop the speed and efficiency of the computer, and then perform the tasks. So, the recent advancements in the field are wearable sensors. So we can depending upon the patient, we should change the sensors, as we all know. As these are very small size, we can easily change their settings and help the patient check his vital conditions like glucose levels, heart rates, etc. Then comes lab on a chip. We can have miniature labs so that the chip which is designed can have a accurate and nice diagnostics. As we all know, chemistry is a very complex thing, um, but the results take much time than usual as we all study. Basically, everyone thinks it's theory, but the chemistry is a very nice subject according to me. The results of chemistry take much time, but using nanoelectronics, the results can be estimated faster in a faster way and very accurately. Then comes neural interface. Neural interfaces are basically the thing which nowadays in movies are popular, inserting a chip into brains and having a controlled neural system by humans. This can be sometimes dangerous, but also very interesting, so that we can control the human thoughts who are turning out in a wrong way. And neural interface is a separate topic which we are going to discuss afterwards. Uh, that's it about the recent advancements and innovations. Uh, the companies and other tech stuff are planning to develop personalized medicines now and sustainable technologies so that they are eco-friendly and energy efficient, so that we can both save the energy and perform tasks in a better way. And also we are thinking to develop advanced computing like quantum computing, which is very complex nowadays, and but the advancements are very fast. The challenges which we are going to face in developing these are ethical conditions, the privacy, data security, and potential misuse of the technology. As we all know, nowadays cyber crimes and etc. Other things are happening very fast, and the reaction time is very slow. Using these computers, there may be someone who can change the perspective of the technology into crime. So which is the first challenge which we are going to face. The second is integration, like the compatibility of the systems nowadays. Creating such a miniature things are very complex, but the miniature things can be developed according to the changing of time. The biocompatibility, sometimes the nano size materials can cause uh, damages to the cells while traveling inside the body due while monitoring. So, but it won't affect that much, as we need to take care of the maneuvering of it. That's it about nanobioelectronics, everyone. So next we are going to have an overview about molecular nanoelectronics. It's nothing but unleashing the power of molecules and having the next wave in the nanoelectronics. Same, we are going to discuss about the introduction to molecular nanoelectronics, then fundamental principles about them, the technology and devices which are already developed, applications in various fields, and also future prospects and challenges. So, basically, coming to the definition of molecular nanoelectronics, it's a field of individual molecules and electronic components which have advancements and produce different things which exhibit unique properties at the nanoscale. Its significance is because as it is a revolutionary idea, and it is very biocompatible and also faster and energy efficient. Like we'll think of having a molecule inside a transistor or any circuit in a miniature way, so that we can perform very high tasks. So the fundamental principle about them is molecular electronics. Molecular electronics is study of molecular structures to perform electronic functions. As we all know, the miniature world is a very interesting world. So using them, we can perform electronic functions which are efficient enough to do anything. Quantum mechanics is a booming subject nowadays. The nano electronics which we are developing can help quantum mechanics very well, so that the interactions of molecules can be easily observed and the estimations of the further subject may be improved. Self assembly of it, the electronics and molecules, depending upon their visualization, may be used to self assemble them, because they have a high sensitivity and specificity. And charge transport, a electrical charge moving through the molecular structures may help it to know how a charge is transferred, and having a deep study on how the exactly the charge is going to travel. So the technologies which are developed are single molecule transistors, which helps in current flow, and which are having potential to change the future computing technologies. Next comes molecular diodes, which are used for the creating molecular junctions, so that the biological functions are run properly. Then comes molecular wires, which are very miniatured, which conduct electricity and can transmit electricity in a faster way. Molecular switches, which can switch between different states using logical operations and memory storage. Then comes applications in various fields. As we all know, computing, we already discussed. Sensing, highly sensitive molecular sensors for detecting chemical and biological agents, so in extreme positions, so that the further complications may be avoided. Energy, innovations of energy storage and conversion, medical diagnostics, biomarkers, etc. The future prospects and challenges which we are going to face are the prospects. First, coming to the prospects, the advanced computing, healthcare, and environmental. As we already discussed, I'm not explaining briefly about it. Then the challenges which we are going to face in nanobioelectronics are ensuring long-term and stability, reliability on the molecular devices. As we already, as I already said, the complications in these inside the biological system depends on the maneuvering of these devices very carefully and handling them with care. Uh, then manufacturing of these processes for commercial use may be very complex, but can be developed. Integration and compatibility of them can be enhanced in such a way that everyone can access it, and the ethical issues which nowadays is common, but we are trying to develop security to it.